Today we're going to continue with the lesson that we did yesterday on laws of exponents. So we're going to be using the same 5 basic rules, but now applying them to expressions without variables, so just numbers. So for number 1, with this one, we know that 1 to any power is just 1, and the negative is inside the parentheses, so it's negative 1 to the 12th power. And because this is an even exponent, that's going to get rid of the negative and leave us with just 1. When we have a negative outside, so for example in this negative 3 to the 4th, this negative is actually outside of 3 to the 4th. So we're first going to do 3 to the 4th and then add on the negative. So we know that 3 squared is 9. 3 to the 3rd is 27. So 3 to the 4th is going to be 27 times 3, which is 81. And so again, because your negative is on the outside, it stays there, and this is going to give us negative 81. The difference between this one and number 3 is that this negative is on the inside of the parentheses. So this is when, if you have a negative 3 to the 4th power, again, because this is an even exponent, it's going to get rid of the negative and just leave us with a positive 81. So number 4 just is reminding us of the rule where anything to the 0 power is just 1. Okay, so let's move on to some slightly more complicated ones. So for number 5, what you need to remember about this one is that when you have a negative exponent, it means that we're going to be changing from the numerator to the denominator or vice versa. So because this is outside of the parentheses, it means that both of these are going to be raised to the negative 3 power, which really just means that we're going to be flipping the fraction. So instead of 2/3, it's going to be 3 over 2. And that gets rid of our negative, so now it's just raised to the 3rd power. So now all we're going to do is distribute the 3, so we're going to have 3 to the 3rd power, 2 to the 3rd power. So we know 3 to the 3rd power is 27, and 2 to the 3rd power is 8. 27 over 8, we can't simplify that any farther, so that is our final answer. Okay, for number 6, this is just reminding us of our order of operations. So this is 5 times 5 squared. This 5 is just 5 to the 1st power. So when we have 2 of the same base, we're going to keep that base, and we're going to add our exponent. So 1 plus 2, this is going to be 5 to the 3rd power, which we know is 5 squared is 25, so 5 to the 3rd power is 25 times 5, which is 125. So this gives us 125. So the thing to remember here is this is not 25 squared. Right? You can't multiply 5 times 5 before you square it. Exponents come before multiplication in the order of operations. Okay, so finally, for a problem that looks like this, what we want to do here is rewrite each of our terms with the same base. So right now our bases are 8, 64, and 16. So we're trying to find a base that has all of these. So with 2's, we know 2 squared is 4, 2 to the 3rd is 8. To the 4th is 16, to the 5th is 32, and 2 to the 6th is 64. So we can rewrite 8, 64, and 16 using a base of 2. So we know 8 is 2 to the 3rd power. So all I'm going to do is replace my 8 with 2 to the 3rd. I still have a 3 on the outside, the exponent, times 64, which is 2 to the 6th power. I still have that negative 1 exponent on the outside of that. And I'm going to replace the 16 with 2 to the 4th. And again, I'm keeping the exponent on the outside. So now we're going to use our exponent rules to combine this. So this one right here, 2 to the 3rd, because it's the same base, 2 exponents, just 1 base, we're going to be multiplying 3 times 3 to give us 9. For this one, we have 2 to the power 6 to the power negative 1. Again, we're going to multiply to give us negative 6. And on the bottom, we have 2 to the 4 times 2, which is 8. And now I'm going to try to simplify this. So first I'm going to move, so this 2 to the negative 6, because it's a negative exponent, I'm going to move it to the denominator. And now it's going to be a positive 6. So let's first combine our denominator. So 2 to the 8 times 2 to the 6. Here's 2 of the same base. So what am I going to do with the exponents? I'm going to add 8 plus 6, which gives me 14. I still have 2 to the 9th on top. So now because I'm dividing, I'm going to be subtracting 9 minus 14. So 9 is smaller than 14, so I know that this is going to end up with 2 on the bottom. Right, so 14 minus 9, it leaves me with 2 to the 5th. And then since there's nothing up here, we're just going to leave it with a 1. So again, because there's more 2's in the bottom, that's where your base is going to end up. And now 2 to the 5th, we actually know what it is. It's right up here. It's 32. So we're just going to rewrite this as 1 over 32, and that's my final answer.